Okay, we're going to go ahead and get started now. I want to thank everybody for coming back again for day 2 of our workshop. My name's Cecilia Solhoff, and I am an outreach specialist here in the Wireless Bureau at the FCC. The first panel today is going to be on policy alternatives. It's going to be moderated by John Leibovitz, who is a Deputy Bureau Chief in the Wireless Bureau here at the FCC. This session is being broadcast on the web, so those of you watching remotely may submit questions by sending an email to livequestions@fcc.gov, and please include your name and the company you're affiliated with. Those of you sitting here, we have some staff in the back with note cards and pens. If you would like to submit a question, please ask for a note card, and they'll collect your note cards from you and get the questions to the moderators. Depending on time constraints and the volume of questions, we'll get to as many questions as we can today. So there'll be short presentations and discussion by the panelists, and then a Q&A session afterwards. And so now, John.
Good morning. Welcome to day 2 of the conference, and I guess you could tell who shows up on day 2 in the morning is they're the true believers of spectrum policy. So our panel is called Policy Alternatives, which is not the same thing as alternatives to a policy. And we've got this actually. I've done a few of these panels, and this is probably will be the easiest one I've ever had to moderate because I'm moderating the moderators. Each of these panelists has moderated a similar panel at some point in the recent past. So this is kind of the greatest hits of receiver performance and efficiency standards policy. But it'll actually, I think, give a good opportunity to put some of the some really well-defined, well-thought-out theories side by side, and people can compare and contrast and understand what the differences are in some of the details, which really matter, I think, when you're doing this thing. So I'll quickly introduce the panelists, and I think what we're going to do is just go right along the row. We've agreed on a 10-minute format. The next panel after this is sort of a free-ranging discussion, so we'll probably stick mainly to the presentations in this particular panel. So first up is Evan Quaral in the Office of Strategic Planning, Plans and Policy at the FCC. Evan, well known to everyone here probably as, for a lot of reasons, as one of the fathers or the godfather of the auctions, and also just sort of a general leading light on spectrum thinking around the FCC. Dennis Roberson, the Illinois Institute of Technology, former Chief Technology Officer of Motorola, brings a sort of, I think, a unique blend of academic and industry experience to this field. Pierre DeVries. Pierre has been working on this exact issue for some time, and really, I think, been pushing the entire community's thinking on the issue with a series of papers and workshops and things that he's conducted, and has a really interesting, comprehensive theory which he'll present today. And then, of course, Dale Hatfield, who everyone knows. So I won't take too much time to introduce Dale, but he's just kind of a treasure of the spectrum world. So why don't we get started with Evan, and then we'll take it from there.
So let me explain the format that John failed to mention. This is going to work like this is going to work like American Idol. That people are going to get voted off until we have one. Yes, until I'm left.
Only because he has the immunity idol.
So I don't know why John didn't tell you about this, and people not only here but viewers.
I have the power to cut off conversation.
Yeah, but viewers out there in internet land can vote as well. Any case, can we have the slides? So what I emphasized in the title here is that we'd be solving the receiver problem without receiver standards, and I thought that was a very modest title. But before going on, I want you to note something very important, that this is joint work with John Williams, who is sitting over there, and truly the brains behind this operation. So if there are any concerns about it, John, John's your man. But honestly, John is an unsung hero of spectrum management, and deserves credit. Well, speaking of credit, we need to distance ourselves from the FCC, so there's a disclaimer so that this presentation reflects John and my views, and it's not an official position of the FCC or anybody associated with it. The next slide is something that we've gone over quite a bit in the previous presentations. We just use different words for saying the same thing, but as a good educator, I know that repeating things 3 times is the charm. So I'll give it one more time. And when it says that there's 2 sides of the adjacent band interference problem, one, the leaky transmitters, which, people before there was a lot of focus on this used to, focus on the fact out-of-band emissions, the fact that transmitters emit undesired emissions into the adjacent band. And that is a traditional externality. It's something that causes harm to a neighbor that's not, compensated and is not agreed on through any kind of market process. And the FCC regulates out-of-band emissions and can, adjust it as appropriate. Really, the focus today is what we refer to as leaky receivers, receivers that admit undesired emissions from transmitters in adjacent band, causing the receiver's interference. And the FCC does not currently regulate out-of-band admissions to receivers. And as the previous day has emphasized, this has resulted in various problems. Before going on to discuss the nature of the problems and our solution, I thought it was useful to just put up an economic framework for thinking about this problem. People understand this, but just putting it down, I think, helps focus one's thought about how you come up with an appropriate policy solution. So, as an economist, the way I would describe the policy goal is to minimize the total cost of interference. And I think you can break it into 3 parts. The first is the cost of mitigation on both the receiver side and the transmitter side. So, and there are various mitigation measures. They include filters, guard bands, and other things that a system operator can do to mitigate interference. But that has a cost to mitigate it. The second is the cost of service loss due to unmitigated interference. So, not all interference is necessarily mitigated, and there's a service loss. Example, like with broadcast television, there'll be interference in some area, and some viewers will not be able to get a station. So that's unmitigated interference. We have a sub-bullet which notes the obvious, but sometimes in high-level discussions, there's an assumption that implicitly they don't take this into account. Zero interference is not necessarily, the optimal solution. It's not like we're trying to have no interference. As I said, we couldn't, locate all the television stations if we had to have, zero interference. And finally, something which I think all the lawyers are well aware of, and some perhaps profit from it, is bargaining and regulatory costs. And that is a major cost. I mean, you might be able to, come to a great solution, but if you spend 10 years negotiating, that's a big loss. And so we're trying to come up with something that's pretty simple. Well, before laboriously going through and building to the climax of why John and I have the perfect solution, let me just state the sort of essence of it in a simple-minded way, tying in with what was said yesterday. Basically, our proposal is to define an interference environment in which receivers must be able to operate. But that environment is not necessarily the existing environment, which is sort of the current policy. Rather, it's an environment associated with our prediction of the highest value use in adjacent band. And currently, we think the highest value use is something along the lines of a modern wireless, a system with a modern wireless cellular architecture. So, you got to be able to operate in an environment essentially next to something that looks like a, cellular PCS, mobile data. And there's a lot of details in that, but it's relatively well defined. And the concept is we want to be putting the spectrum to its highest value use. And how long it takes to get there, how it applies to new allocations versus legacy systems, we talk about that, and there's plenty of things to be worked out. But that's basically it. No receiver standards, an environment that you have to deal with, an environment that makes sense in terms of the highest value use of the spectrum. So, how does that compare to the current policy? And I'm aware that this isn't exactly written down as far as I know, but this is the default assumption for the current policy. The current policy is based on the longstanding concept of first in time, first in rights. So for a new allocation, when a new allocation is established, the new allocation must protect existing systems in adjacent bands from any interference and self-protect against interference from those systems. So, the previous guy in adjacent bands, they have a right to the environment that they found when they were there. New person in has to protect them, has to live with what they got. An existing allocation, and this is just the flip side of it, is once you're licensed, you're an incumbent and you're protected against subsequent systems who must also self-protect against that system that's now an incumbent. So again, it's first in time, first in rights. It's a sequential approach. We change things, but that is the default assumption. That you have the right to the way the situation that you found yourself in when you got your allocation, and then once you're there, nothing changes, unless we do something extraordinary. Well, what's wrong with this system? Well, yesterday was a full day of saying what's wrong with this system, but I think it's worth trying to flesh that out. And we have 2 slides on this, but the bottom line is it wastes a large amount of spectrum. A large amount of spectrum can't be fully used for a long period of time. That's the bottom line. What's wrong with it? But let me start at the beginning and get there. So the first thing that's wrong with it, with this first in rights system that never expires, is there's insufficient self-protection over time. And why is that? Because people self-protect only against existing uses. Their incentive is to do the minimum amount to protect themselves against the existing uses, but the existing uses aren't necessarily the highest value uses. So then what happens? Well, then you end up with receivers that are vulnerable to interference if the adjacent band is repurposed to a higher value use. such as wireless broadband, such as like the problem with GPS and light squared. I mean, the receivers, they were fine, protecting against existing uses. They weren't fine when the spectrum would be repurposed to a higher value use. And then the third point, which also you saw with light squared, the problem is, once you've deployed your systems, once those GPS devices are out there, once the TVs are out there, adding self-protection can be, retrofitting can be a lot more expensive than if you did it initially. I mean, often it's possible, but it's more costly. So the second point, which is sort of an implication of the first point, is of what's wrong with this system, is that it places costly restrictions on spectrum use in adjacent bands. Because the adjacent band has to protect these existing vulnerable receivers to a no interference standard. This can require very strict power and deployment restrictions. Like in the case of light squared, that they can't do something that might be very valuable. Now we note, as a good economist, that it may be possible when the value of additional self-protection is greater than its cost, that there could be a negotiation between the two parties, as there was, between light squared in some sense and the GPS community. But that negotiation can be very difficult, particularly when there's, like in GPS, there is not a single system owner. There's many interests. So, in principle, you could work it out by some kind of bargaining, but often the bargaining costs are too high. Bottom line, you end up with a large amount of spectrum that can't be put in its highest value use. It's restricted for a very long time. Well, now I just want to say, so what is the objective of our interference policy? Number one, we want to create incentives for efficient management of spectrum. I'm not going to have time to go into exactly the details of it, but it's not just a regulatory regime that we tell you what to do. We want something where the parties have incentive to do the right thing, or approximately the right thing. We want something that it's sustainable, dynamically efficient. What we mean is over time, as circumstances change, we want parties to have incentive to do better, as the cost of mitigation gets less with Moore's Law and so on. We don't want a lot of bargaining costs. And we don't want to impose undue burdens on receivers. Yes. Anyway, we propose to apply this to basically the sweet spot, 300 megahertz to 3,000 megahertz. So now the proposal. I'm sure everybody is on the edge of their chair. Okay, there are three parts to the proposal. The first part says applies to new allocations. So what we're saying is that new allocations must avoid encumbering adjacent bands targeted for flexible use. So when a new allocation is being established in a band adjacent to a band that's likely to be repurposed for flexible use, and I say likely because if there's no chance it's going to be repurposed, then there's no reason to incur these costs. Then the new allocation has to protect not only existing systems, but the future flexible systems in that adjacent band. And we have a specific definition what we mean by a flexible system, and it's basically something that looks like a modern wireless cellular system. And then the point that much of this discussion is about, it has to self-protect against interference from those systems. Not the systems just that are there now, but what would be there in the future based on this specific definition. For bands that there's no chance of repurposing in any reasonable time, the current policy of first in time would apply. The second part, which is really the most relevant, is what do you do with legacy systems? Well, the notion for legacy systems, what we say is we would protect them for a limited amount of time when an adjacent band is repurposed for flexible use. So this would be sort of like, GPS and light squared. GPS was a legacy system. We're not going to, flash cut. And the basic idea is that we would give the legacy system a certain amount of time based on the replacement cycle of their receivers. And the third part of the proposal deals with what happens when you have a band, an adjacent band that is already allocated for flexible use. So like WCS was allocated for flexible use, but it couldn't be fully used because it had to protect the legacy system of SDARS. And there too we would phase in this self-protection regime, over some number of equipment life cycles. The next slide, I will just say that we will meet all our objectives with this proposal. But I don't have time to go through that. But let me just emphasize something which is a point which is often lost in this whole notion of how to deal with the problem. The problem is not just a receiver problem; it's a system problem. And under this concept, where the licensees have to live in a certain environment, the licensees decide how to self-protect their systems. And so the receiver owner can self-protect by adding filters to receivers. They can increase the strength of their own signal. They can move the receiver away from the band edge. Having an internal guard band. They can accept additional interference. It's not just about receivers. It's about leaving it. It's about how to operate in this environment, and we leave that to the system operator. And when there's no system operator, but there's no, then there's some discussion. But there would be no FCC receiver standards. And now I have a very short slide on details that need to be worked out.
The fine print.
Yeah, the fine print before you sign on the dotted line. I think the number one issue is commission credibility. What happens? We say, you've got a certain number of years to be able to operate in this environment. They don't do it. We now try to, the adjacent band operator, puts in their system and they want to operate. This would cause actual interference. The legacy system comes and whines to the FCC. What are we going to do about that? Possible things. If the FCC doesn't have credibility, this may not work. Do we need a system of system certification, receiver labeling? What do you do? Yes. Another point is, I've assumed that John and I assume the most valuable use is a cellular-like system. Is that a good assumption? Another thing is that we haven't gone into is, well, what kind of system? Is it FDD or TDD? That makes a big difference in terms of what you've got to be able to live against. Another issue is, how many system life cycles is sufficient? Is it, one life cycle or many? What do you do about systems where you don't have a system operator, like, TV or GPS? And finally, a thing where Pierre, and this is a major area where Pierre, John, and I disagree, is how do you regulate power? Because this is a big deal in terms of how you define the environment that you have to be able to operate in. John and I, propose that we stick with the existing system. Well, not perfect. It's simple, which basically what we do is we regulate power at the transmitter as opposed to defining, power on the ground, PDF. So what this means is that if the adjacent operator is meeting the rules, that all their transmitters, are meeting the rules, then you've got to live with it. We're not giving an absolute level of protection. We're just saying this is the system that's going to be next to you. This is how it's regulated. If you get interference, it's your problem. Fix it. Okay, done.
Thanks. So we'll go to Dennis. Before we do, I just want to remind people, all the panelists for this panel are also on the next panel, which is a 2-hour discussion. So we're going to hold questions till the next panel.
They cut off my thank you slide. Thank you.
Dennis.
If we could have the slides.
But if you get your slides, then how am I going to be the winner?
No, we're going to come to that momentarily. So I'm going to submit the case for receiver standards and regulations, full stop.
All right.
I, too, have a disclaimer. The thoughts are expressed in a provocative manner, purposefully, to recognize the elephant on the table. And I would like to submit up front that in the spirit of collegiality and in the spirit of this disclaimer, my slides represent the right direction. Those presented by my colleagues represent the wrong direction, and Dale at the end will validate that fact. So just so that it's clear up front and we have no confusion.
Okay. Vote for me.
The wireless systems, just a brief bit of review of what I talked about actually to start this event, but I think it's really very, very important. Wireless communications does exist as a system of transmitters and receivers that operate in a harmonious fashion with one another. Each contribute to the success of the communications, and we have to recognize them as equal partners as opposed to the unequal position that has long existed where transmitters are regulated, are standardized, and receivers are good luck. Historically, we didn't have this problem at all in the days of Marconi, spark gap, use all the spectrum, good luck, it's a wonderful world. That was the way we started. And we saw this as we started yesterday. We've come a long ways from that period of time, and we need to recognize that we're in a totally different regime. We have moved, as we invented new wireless technologies, to a position of an ever more complex set of standards-based sharing. Often there's discussion about we're moving to an era of sharing. We have always been sharing spectrum. We just have different ways and an ever-evolving approach to that way of standardizing our methods of sharing. Initially, it was all about frequency, power, geography. More recently, it's become focused on time, and now we're moving into orthogonal codes and diversity. And one of the conversations this morning, why didn't you talk about MIMO when you were giving your introduction? And we could talk about spatial diversity and time-based diversity and all the rest, but we're moving into these complex realms, and we need to recognize it, and we need to develop the structure that allows us to take advantage of these technologies as we move forward. Our reminder again, transmitters don't interfere with one another. Transmitters, and in fact, overall, the only place that there's any interference is at the receiver. We need to recognize that and therefore put the focus on the receivers as opposed to the transmitters. And that does fit into this regime of spatial, spectral, temporal, coding, and diversity techniques to achieve the ultimate desired result. Yesterday, again, a review. You can't have an operating system if you only put filtering at the transmitters, if you only regulate the characteristics of the transmitter. It simply doesn't work. The systems can't work if our focus is only at the transmitter side. So it's a key direction that we have to recognize. So moving in from the day that we have just experienced, the observations that we have is that, again, radio operation is a systems game. It is transmitters and receivers cooperating together. Peaceful coexistence is the approach. Ideally, it's not just the transmitters and receivers in one system, I might add. It's certainly not just one transmitter with one receiver. It's not even the transmitters and receivers within one system, a cellular system, for instance, as Evan has spent a focus on that. But rather, you ultimately want all of the transmitters and all of the receivers to be cognizant of one another and to be operating in a regime that recognizes the characteristics, recognizes the environment that is going on around you. This is going to be particularly important as we move into the new world of dynamic spectrum sharing, where an understanding of the environment is going to become ever more important. In particular, in session 4, yesterday, the session that I had the wonderful opportunity to moderate, we observed the severe challenges that have existed. There were very, very good people on that panel, very good people who had worked together, who demonstrated that interaction over time. And yet, they failed up front, ultimately succeeded in some cases, but even that was the costly, many, many years kind of environment to get to an end point. If we were sitting in the circumstance where there was a complete understanding and a requirement for the receivers to perform against a set of standards, the world would be much, much better in each of the cases in session 4. In session 5, we observed that most of the major systems actually have standards in place. Cellular, with my world of Motorola, the standards there, and even in some of the other companies I've been involved in since then, are very, very focused on very particular standards for how receivers operate. And yet we've not tended to make those receiver standards visible to the wider world. They're mostly standards that are requirements placed by the operators on the providers of either the chipset or the systems. We need to make those standards fully visible and even require adherence to those standards through regulation. So, the conclusion. We do have crowded airways. We are getting to a place where we can no longer neglect this world of receivers. Just as the days of Marconi, when we didn't really worry about the allocation of spectrum, those days rapidly dissipated as we needed to share. We need to move to the next level of sharing, and the time is now to move forward. We have to do it not only to match and meet the problems that exist today that we've seen in this event, but for the future, it's going to be much, much more important, because we are, whether we want to be there or not, we are moving to an environment of dynamic spectrum sharing, where we will have devices that are entering and not having the kinds of long-term difficulties that we've talked about, but short-term, millisecond by millisecond sharing of spectrum. Without a full understanding of receivers, that new world can't possibly exist. So we need to move forward. It's critical. The closeout, I was joking about this beforehand, sound like a politician with this one, but it really is good for the industry, the providers of the technology, the suppliers of services, but it's also good for America. It's what FCC is all about, is providing the best utilization of the spectrum for the population of the United States. So with that, and with 1 minute left as opposed to 2 minutes in the negative, I will yield the floor to my colleague and move forward.
Thank you very much. Wonderful. Thank you, Dennis. I think it's pretty much guaranteed that I'm going to lose this contest because, in fact, what I'm going to be proposing is a middle way between the two extremes. And in D.C. today, compromise always loses. The title of my slide deck is Optimizing Receiver Performance Using Interference Limits. And to just make a point about the word optimizing, who does the optimizing? I see the optimization of this system being done by the manufacturers, by the users, by the operators, not by the FCC. The FCC or the regulator creates the context in which this optimization happens. And it's not just a question of minimizing the cost of interference. You also have to look at the benefits that arise. So it's actually maximizing the total benefit that we get from wireless systems. So I'm going to be taking my time to sketch a proposal. I'm going to focus more on the what than on the why and the how in the time that I have. So I'm very grateful that we have the captioning, but unfortunately it creates an interesting co-channel interference problem. So I actually tried to adjust my signal to work around it, but it doesn't really go all that well. I was very pleased, but they don't see this. I was very pleased with the title of this slide, which unfortunately most of the audience can't see, and it says, lots of old, a little new, mostly borrowed. So this slide, in fact, one can also describe as clambering up the backs of the giants, which is what I've been doing. These are some of the giants whose work I've used and built on. I'm not going to go through all of them. That would take all 20 minutes. Just to call out a couple, Dale Hatfield, obviously, who's been thinking about this problem longer than pretty much anybody, and I've benefited a great deal over the last 3 years. And also Vanu Bose, who I've been collaborating with on another project recently. It's been wonderful to test the ideas with them. So let's talk a little bit about receiver management. And so this slide is about receiver management strategies. And it was really interesting. Recently, I was rereading a wonderful 2003 NTIA report on receiver spectrum standards. And it helped me to realize why some people looked at me quizzically and other people said, duh, when I explained what I'm going to explain to you. And it's a terminology problem. So this paper, in fact, says there are two kinds of receiver standards, and here they are. So the first is a description of the radio frequency environment in which the receiver must be designed to operate. And the other one is a specification of the minimal performance requirements, and then follows a long list of receiver parameters. What's confusing to a newcomer like me to this field is that the word receiver standard sometimes refers to both those things, but sometimes, and I think usually, only refers to the second. So I'm in fact not going to use that word if I can. The thrust of my conclusion is that the first one, a description of the signal conditions, to use the language that John Henderson was using yesterday, is always necessary. We need to get to a point where we do that in all cases. Specifying these device performance requirements, it's complicated. Now, that's a reference for those, everybody's now on Facebook. You know the relationship status in Facebook where you pick it's complicated? defining performance requirements is complicated. It's complicated technically, and that's what session 5 was all about yesterday, how complicated this can become and how industry-specific it is. And in fact, because we're talking about standards, it's always backwards looking. But sometimes it's unavoidable. And I'll talk a little bit about when we need to do that as well. So let me describe what I mean by receiver interference limits. So here's the definition. It's a delineation by the regulator. The regulator could be the FCC or the NTIA or, in fact, a band manager in a sharing situation of the radio interference environment that the assignee of an operating right should expect to operate in without being able to make a claim for harmful interference. And I contend that the linkage between defining the interference environment to this, which is effectively an objective definition of harmful interference, is what's going to help us move forward. Just to give you a hypothetical example of what a definition like this might turn into in the end, and this would be, imagine the kind of service that one has to live with is a handset, cellular handset. The assignee would get this as part of their rules. It says the aggregate field strength that you need to live with, measured 1.5 meters above the ground, will not exceed some field strength per megahertz in band for you, some field strength bigger, obviously, in this, let's say, 20 megahertz above and below the band edge. And beyond that, all bets are off. You've just got to deal with everything that's out there. But because radio is statistical, those limits will be observed at some percentages of locations and some percentage of time. Now, there are lots of lawyers in the room, I'm sure, who like to think in terms of words. I like pictures, so for those who like pictures, here's a simple graphic that tries to explain the same thing. So in the horizontal plane, we've got essentially spectrum. It's a subset of electrospace. It's frequency and space, one dimension of space. And that little square, in fact, is where one's allowed to operate in. So that's where you're going to do the assignment. And field strength is the metric. And so this is what an interference limit actually would look like. This is a relatively simple one. You can see it's symmetrical in frequency above and below the assigned frequency. And in fact, the surface outside that you have to live with is it's flat over space. If in fact the surface, let's say on the lower side, on the left side, were a fixed antenna with a fixed location that didn't change, like a radar, for example, certain kinds of radar, or like television, that would in fact slope. That field strength thing would slope. And you can see that you specify the field strength in band, out of band, and also the probabilities. So let me give you a simple example of how one might think about constructing this. Another chart. So here I've collapsed space. So space goes away, it's in the plane. And so we're looking at frequency across the left, and I'm plotting field strength. And because field strength varies from place to place and from time to time, the noise floor that I show there doesn't stop, it fades out. So there's some cloud. And in the middle there is this band that we are allocating. So we want to give a receiver interference limit to the operator in that band. Now, let's forget about the service that they're going to put in there. We're going to look at the signal conditions around them. And so here they are. So this is what we have. In band, it's gone up a little bit because of everybody adjacent. And then we have a number of different services in the adjacent bands. One characterizes those services by describing what the current interference level is. That's the dotted line, the dotted green line, with the probability that it isn't exceeded, percentage of space, percentage of time. Now, if you were to do a simplistic receiver interference level, you just say, well, I'll just put a surface on top of those because that's what the incumbents are there. We're not going to make them liable for harmful interference by creating this new protection limit, and then we're done. However, you have this problem that John and Evan were talking about, which is that band on the right, which is currently quiet, what if you expect that it's going to be busy? So what you do there is you impute an operating limit, a field strength that's going to, in fact, in the future be there, and that's your planning limit. And then you use those as the lower bound for your receiver interference limit. And there it is. You can see it's the blue line. It's some low value in band, some higher value out of band with a probability, and it stops at a certain point. Now, you can see that this is, I think, a pointer towards how one solves the problem in practice, implements the solution that John and Evan were talking about earlier. I would claim it also has other benefits. One is you can see that the transmission permissions, the green dotted lines, and the receiver interference limits are dual to each other. If you have the one, you know what the other one is. And so this is a way in which you can do dynamic sharing. Because if you know, for example, a service that's an incumbent and you know what its protection needs to be, what its interference limit is, you know that you can't allow a sharing system with it to exceed those limits. And likewise, as I've done here, when you have a system that's already incumbent, you know what the interference limits have to be. Just a couple of words about how one actually might do these probability measurements. How do you determine the signal environment? So imagine that the blue area is this, the license area or the operating area that an assignee has. And by the way, I keep using the word assignee for the lack of a better term. That's a licensee. It could be somebody in the federal system that has an assignment. It could, in fact, be unlicensed devices. So in that assigned area, you have verification areas. I think for the kinds of services we're talking about, 5 kilometer by 5 kilometers square is about right. And for each of those areas, you put down a grid of measurement points, and those are the little red squares. Let's say you put down those on a 100-meter grid. That gives you 2,500 points. Get decent statistics. And essentially, you count the fraction of those locations where you observe that the energy is greater than E. And that number needs to be less than this probability number that you've defined. Now, how do you do the measurements? Well, you measure in time. And so in time, you have verification windows. Here, it seems reasonable. You have something of the order of a minute. If you measure every 100 milliseconds, you get 600 measurements. And so in every verification window, the number of observations where it exceeds that value E needs to be less than 1%, say. So you might say, my goodness, this sounds like a lot of work. How do I actually do this? One of the things which I should have pointed out earlier is that even though I'm using some of the same terms, and this might remind some people in the room about interference temperature, this is not interference temperature. It's the same notes, but it's a different song. It's actually the same genre, and it's the interference blues, but it's a different song. And one of the differences is that here you only need to do these observations when there is a problem. You don't have to measure it all the time for every place, everywhere. And there are, broadly speaking, two ways you can make these observations. One is by going out and measuring, and the other is by doing modeling. And I happen to prefer modeling, and we can talk more about that later if there is time and interest. But just to show you what that might look like, this is Ofcom's commissioned study by a company called Transfinite, very interesting piece of work. The report is called The Derivation of Power Flux Density Spectrum Usage Rights. And what they've done here is they've modeled the handset population in the UHF. And so on the vertical axis, you get percentage of locations. So this is a cumulative distribution function. And you can see that fewer and fewer percentage of places you go over to the right have really strong power. So if you want to read off, let's say, 5% of locations, what is the 5% of locations value? You draw the line across from 5%, and you read off the curve. Well, that's actually minus 81. And in this case, they use dB watts per square meter per megahertz. And in fact, if you translate that, that's 65 dB mu, which is what I had in my example earlier. Now, when we spoke earlier, when I started this, I said that receiver interference limits were necessary but that they were not necessarily sufficient. And so you need additional measures for those cases. And so why might they not be sufficient? Well, what if the users that you have can't be trusted to deploy receivers that will actually operate given this interference limit? Because essentially the regime says, here's the environment, you need to operate in that, and if your device can't cope with this interference, don't come complaining to the FCC about harmful interference. But what if, for example, you have what Dale calls decoupled receivers, where the licensee doesn't control the receivers, like in television, many satellite services, where people can just flood the market with receivers that don't necessarily work. Another case here is unlicensed devices. There is no licensee, and so it may be that somebody has a business model where it's cheap to just build unlicensed devices that don't cope very well. And in fact, in Dave Gurney's slides yesterday, we saw how poor the out-of-channel rejection is for Wi-Fi devices. And in fact, I think, and I will here use the dreaded nightmare words, the 3 words that cause more fear than any garage door openers, it may be that in bands where they're sharing with federal users, not even licensees might be trusted to do the right thing. So you got to do something about this. So what do? So this is where I suggest you have to add device performance requirements, what some people sometimes call receiver standards.
I knew he would come to my position sooner or later.
Compromise. You can declare victory, right? And so there are 2 flavors of this, increasingly stringent. The first is self-certification. And this is where the manufacturer or the retailer of a device essentially makes an undertaking that their device will function satisfactorily given the interference limits. And they get to choose what satisfactory means because it's a question of what kind of service they're selling. Are they selling a consumer-grade device, which is fine, doesn't really need to perform all that well? Are they selling a professional industry-grade device, which really needs to perform very well? They can do this either as a warranty of fitness, which goes on the box, and in fact, if they lied, that's false advertising. Or the FCC might require that they self-certify, that they in fact, as part of the certification for their devices, submit a test plan to the FCC that lists all the parameters through which one can test that their devices work. This means the FCC doesn't need to decide what acceptable performance is or how you measure it, but they can check to see that this is an acceptable inventory and that it's met. Now that itself might not be acceptable either in some cases for some people. So for example, it might be that there's a safety of life issue in aviation where you absolutely want to say, here's a standard, you got to meet that. Or it may be that for decoupled receivers and unlicensed devices, one can specify a very simple minimal standard. One can debate about how long a minimal standard stays a minimal standard once the sausage machine starts grinding, but perhaps specifying front-end selectivity. And so this is the wordy version of the additional measures. The pictorial version of the cumulative requirements looks like this. For all assignments that we make, right now, today, we put transmission permissions on them. We associate these rules. What I'm proposing, and what many people are proposing, is that in fact there are receiver interference limits that are associated with transmission permissions in all cases. There are going to be special cases where you need to do more, but they're a subset where you do either self-certification or in some even smaller set, mandated performance. Now, one of the reasons I'm in favor of the receive interference limits is I suspect, I am not a lawyer, I'm not a double E, but I suspect that the FCC needs no or less additional statutory authority to do receiver interference limits because they would just be a definition of what harmful interference, which is already in the rules, actually means, than to go the route of definitely mandated performance. So to close, let me just say a little bit about the why. So what are the benefits of this approach? And I've picked 3, the rule of 3 bullets for each. The first is business value. Actually, it's not just business value. It's value for society in helping to create a flourishing market in devices and uses. The first reason why it's useful there is that the regulator delegates these system design decisions, how to play the system game, how to make the trade-off between what your transmitter does, what your receiver does. It delegates this to the players. The second is that it reduces business risk. So for the receivers, if you have interference limits, you know that you essentially have a guarantee that nobody's going to be allocated next to you whose power is going to exceed that limit, so you can design your system. And for transmitters, you know that somebody with, quotes, poor receivers isn't going to be able to make a claim for harmful interference because they have to, you know what they have to deal with. And in fact, for both parties, because you know the interference environment better, it helps you estimate your deployment costs. And lastly, to the place where I started, optimizing, it increases economic efficiency because players can adjust these much clearer transmit and receive rights by negotiation. There's also value for the regulator. The first is, as John and Evan have described, it allows for the future repurposing of the rules. It establishes a regime which is technology neutral. It doesn't get into the detailed standard specifications that you do with device performance specs. And last but not least, as Dennis was pointing out, the future that we're facing, it actually facilitates dynamic sharing by this automatic inference of the permissions. There's a lot more to be said. There are some backup slides which will be on the web, so after this slide there are a few more. There is a link there to a roundtable that we had at Silicon Flatirons last year, where you'll find very interesting comments by some very important people and very thoughtful people and reading. There's a 2-pager that I've written that summarizes this, which is at the third link. There's also a white paper which is currently being written, just not quite pretty enough to share with you today, but if anybody's interested, please let me know. Thank you.
John, I'll look down to you. I guess we're about out of time for the
Well,
first...
I think we started a few minutes late, so...
yeah.
Yeah.
Okay, yeah, I could do it either way. I could tack it on to the start of the next or at the end of this. Yeah, okay.
I get a bonus if it ends on time. I missed it. Sorry, you might as well talk now.
Well, of course, first of all, it's great to be back here at the commission, and I really appreciate the opportunity to be here on this particular topic. I sort of sat back and tried to think about yesterday and what I've heard this morning, and so what I thought I would do is just sort of talk about what I've heard in terms of policy alternatives. And let me start. I think my sense, and I don't want to call it consensus, but it seems to me the sentiment is against do nothing. I mean, if I heard any, I think we're finally at a stage that the recognition that we really do need to do something about receivers. Now, we can have big battles over exactly what that should be, but my sense is, like I say, that there's pretty strong sentiment towards doing something about receivers. And then if you cross that threshold, it seems to me it gets between this choice between this being teed up here very nicely today is specifying the environment within which the receiver must operate, which is receiver interference limits, so forth, that Pierre was talking about, versus Dennis's eloquent plea for specifying actual receiver standards. Here again, it seems to me that the sentiment seems to be in the direction of giving manufacturers, system designers, as much flexibility in how they deal with the interference environment. So it seems to me, and I'm maybe a little bit thin ice, but it seems to me that there seems to be some sentiment, at least, towards specifying the environment rather than detailed receiver standards. I think yesterday and today, and with Pierre's performance, presentation, there's these special cases of what we refer to as a decoupled receiver problem, the case where there's no connection between the licensee and the equipment vendors, or the case where there's unlicensed receiver devices. And I thought yesterday, I believe, from the NTIA side, the issue of weather receivers was brought out, where the government's transmitting weather information for its own use, and people are piggybacking on that and built their own receivers or so forth, and are piggybacking on that, which is sort of a nice, from an innovative standpoint. But then, of course, those devices are not registered. You don't know much about them. You don't know where they are. You don't know what their characteristics are, and so forth. So it's that decoupled receiver problem is significant. And I think the unlicensed is the same thing that Pierre talked about. And of course, he did say the dreaded garage door opener, the dreaded 3 words. And I think that's where you get a de facto reallocation, because you get so many devices out there as a political matter. You can't fix it. And then, sort of, if you sort of are following along with me, then if you sort of say that who establishes the environment within which the receiver must operate, if that's sort of the default notion, then it seems to be one of the strong things I got yesterday. Well, let me say that what the 2 choices are, it seems to me, is largely something that's largely industry led, what we call multi-stakeholder groups, such as 3GPP and IWPC and so forth, where it's led by the industry versus government establishing the environment or specifying the environment through some sort of combination of FCC and NTIA and perhaps specialized agencies like the FAA. It seems to me, here again I may be inferring more than I should, but it seems to me the sentiment is towards the multi-stakeholder solution. And I'll confess, sitting here yesterday, my respect for those multi-stakeholder groups ran up rather significantly. Now, I confess I may be biased, because some of you may know I'm chairing something called the Broadband Internet Technical Advisory Group, which is indeed a multi-stakeholder group, and I've had some now first-hand experience, and I do believe that such groups can be effective, as opposed to getting into the comment and normal comment and reply comment cycle, so forth, which causes delay here. So, but there's sure some caveats there. It's one thing to look at 3GPP, which is primarily focused on stuff within the bands that are sort of their own bands, their own wireless bands. And then you need that whole ecosystem that they talked about, and everybody's sort of playing nicely because they have this common objective of making the whole industry grow. That seems to me is fundamentally different when you have, on one side, if you have, for example, just a hypothetical military radar on one side, and you have commercial operations on the other, and then you try to extend that multi-stakeholder environment into that, because then you have different cultures, entirely different cultures. As pointed out, it's hard to know who to negotiate with on the other side. So I think we have to, while I'm really in favor of the multi-stakeholder approach myself, I think we have to be a little bit cautious, since we haven't used, I don't think this morning, good fences make good neighbors. From
Robert Frost.
Yeah, Robert Frost. Yeah. Let me say, it's one thing if you got 2 farmers on each side of the field. They're sort of in the same business. They sort of understand each other, and they have to deal with each other, kind of on a routine basis. But what happens if there's a farmer on one side and there's a gravel pit operator on the other? Then it gets a little harder, I think it gets a little harder to reach some consensus. So I think we need to temper our enthusiasm a little bit for the multi-stakeholder group with that reality. And then we have the issue of how you evolve this specified environment over time. We can make RF amplifiers that are more linear, reducing problems. We can make better filters and so forth. So how over time can we, because the spectrum gets more valuable and the cost of having greater linearity and greater selectivity falls because we get that A to D converter right out there at the antenna someday. If we can really get in that direction, then it's obvious you need to evolve over time because spectrum more valuable and the way of saving it is the trade-off is obvious. And then I don't think we talked as much here than who resolves or even adjudicate interference disputes after the environment is specified. What are the associated incentives and penalties? On the industry side, we have frequency coordinators. I've always been a fan of frequency coordinators resolving a lot of these issues before and never getting them to the commission. So I think industry voluntary activities, for example, the frequency coordinators, and then of course government. Flip side of that is the government through its field operations bureau, OET labs, and so forth on the other side. Let me sort of stop there. I do want to pick up just one further thought that Dennis already teed up, and there is a disconnect here. A lot of what I heard yesterday and what I've heard this morning, except apart from Dennis's comment, is our model seems to be still a little bit about where the spectrum is shared in a static sense when we look at that chart, that famous NTIA chart. But as Dennis's work shows, a lot of the spectrum, of course, is not used an awful lot of high percentage of the time in a high percentage of locations. And that's, of course, has led to a lot of research in finding ways to dynamically share spectrum. We have the example, the TV white space, the sharing in 5 gigahertz government radar band. But these terms, the dynamic frequency selection, opportunistic sharing, somebody said spectrum scavenging and so forth. If we're really going to get maximum use out of the spectrum, we're going to have to go to those much more dynamic. And in some ways that sort of erodes the notion of allocations in the traditional sense like we were talking about them yesterday, because it's much more opportunistic. And so I think we have to come to grips with that. And of course you throw on top of that service flexibility as well. And I had a feeling that we were driving, really fast down the road, but driving by looking in the rearview mirror in some of the discussion, not recognizing fully the dynamic what's happening among our friends in the research committee doing the dynamic spectrum assessment. So in my humble opinion, I guess we need to look more in the direction of this dynamic spectrum sharing if we're going to specifically increase efficiency. So I think I'm probably well over what I say. I do it in 10 minutes, so apologize for running over, and I'll conclude with that.
Okay, so we'll take a 5-minute break and then reassemble with this panel plus other people and take questions. Thanks.
Last session now. So the last session today is going to be a panel discussion. There won't be any formal presentations made. So this is the point where if you have your questions and answers questions from the last panel, the policy panel, or any of the other information you've seen over the last 2 days, now's the time to submit your questions. Again, if you're viewing this remotely, you can submit your questions by sending an email to livequestions@fcc.gov. If you're sitting here in the audience, there's staff in the back with the note cards and pens. So the last session today is going to be moderated by Dale Hatfield. Dale is an adjunct professor at the University of Colorado at Boulder. He probably needs no more introduction than that. Everybody knows Dale. So with that, I'll turn it over to Dale.
Thank you very much, and welcome to the final panel. I want to thank Julie and Walt Johnston and Mike Hall and so forth for inviting me to moderate this final panel. As I said before, it's always great to be back here at the Commission. And I'm, of course, especially glad because this topic of receiver efficiency and receiver performance is near and dear to my heart. If you'll bear with me, you get older, you always need to tell a story. And somewhat. I don't know why the reason that is, but nevertheless, my first experience with adjacent band interference came in 1954 or 1955. I'm not quite sure which year. Over 50 years ago, when as a young ham radio operator, my parents got a call from a neighbor saying that my 6-meter ham rig was interfering with their reception on TV Channel 2. And this is indeed the adjacent band problem. The two bands, the ham band is right adjacent to Channel 2. And so I found out right away about good fences and good neighbors again, or in that case, maybe bad fences make for difficult neighboring situations. The interesting thing about it, philosophically, that we had, there was I don't know whether they still exist or not, a TVI committee. The amateurs had a TVI committee who had some pretty seasoned engineers, and they would come out and help you resolve the interference problem, which is sort of what we're talking about here when we have industry, a multi-stakeholder group sort of working together to try to solve a problem. Okay, but let me turn to the purpose of this final panel, which we have just really a collection of tremendous experts, and who I'll briefly introduce in a moment. But what we're trying to do is pull together what we've learned yesterday and so far today. And we've heard from all parts of the ecosystem, and I've found it just really fascinating. So what we're going to try to do here is pull out some thoughts on how the Commission and NTIA might move forward in terms of dealing with this receiver performance issue. I would hope and urge that we come up with some actionable suggestions and recommendations based upon the conversations we've heard so far. I did think after the introductions, I would give each panelist an opportunity to give a short opening statement, if you'd like, and then we'll go up and down the panel for a while, exchanging some views among ourselves, and then we'll turn to some questions. I've already got a fairly nice stack of questions here, and I would urge you here in the audience and also out remotely to submit questions if you've not done so already. So let me then briefly, if I can find my right notes here, introduce the folks on the panel. To my immediate left is Doug Zecker, who's the Chief Technology Officer and Senior Advisor for Spectrum at NTIA. I'm going to take the precedent that Dennis set yesterday by doing a little shout out. And of course, Doug also holds a professorship at the University of Colorado at Boulder. Dennis, I just couldn't resist the opportunity to talk about my home institution. To the left is Evan Quirrell, who again needs no real introduction. He is somebody who I've had just tremendous respect for over the years, and he's Senior Economic Advisor in the Office of Strategic Planning and Policy Analysis. To the left of him is Dennis Roberson, which he holds the winning thing here as far as you've now been on four. That's right, fourth. So, and of course, I really enjoyed Dennis's earlier presentation. He's the vice provost at the University of Illinois. Why did they? IIT. We went to IIT at one point. To Dennis's left is
another very distinguished alum.
Is Pierre DeVries. Again, one of my colleagues at the University of Colorado. He's Senior Adjunct Fellow at the Silicon Flatiron Center at the University of Colorado at Boulder. To his left is Steve Sharkey, of course, another person well known in the area of spectrum policy. He's Chief of Engineering and Technology Policy. Federal Regulatory at T-Mobile. Let's see. To his left is Larry Crever. He's Vice President of Legal and Government Affairs at Sprint Nextel. To his left is Henning, and I always have trouble, Henning, with your last name. I'll try the best I can. Schultz-Rennie. Is that close enough? And, of course, he is now chief technologist here at the FCC. Then to his left is Dean Brenner, who's Vice President, Government Affairs at Qualcomm. Another familiar person in these discussions. And then at the far left is Steve Wilkes, who's also been on one of the earlier panels, who is distinguished member of the technical staff at Alcatel-Lucent. So with that, I'll just go right down to the left, giving everybody a chance to make a few opening remarks before we turn it to a more open discussion. So, Doug?
2 minutes?
A couple minutes, yeah.
So I think I'd like to start. Obviously, everything, so much has been said. It's kind of hard to find something new to say about this. But I do want to turn back to why we're here and really what motivated all this. And I think Julie and others can agree, was a letter that Ed Drusella and I wrote some weeks ago on Light Squared. And in that letter, we had recommended that we start looking at receiver standards and directed NTIA specifically to look at reviewing receiver specifications in the federal space, asked FAA to look at their specifications, and asked FCC to likewise look in the non-federal space. I bring that up because that is an important starting point and I think a big motivator for why we are all here today. But again, that's not enough. That's a starting point. We have a lot of other things that we need to get going in this space. I think we're all in agreement that some kind of, whatever you want to call it, receiver interference limit or some other model makes sense. I think we all would prefer some sort of multi-stakeholder, industry-led effort to start thinking about these. But I do think that in the long run, why this is so important is it is a part of another great interest of mine and Dennis and others here, which is movement toward more dynamic spectrum access. And I don't think you'll be able to do DSA, it won't be able to fulfill its promise without thinking of the receiver, because again, as has been said so many times, this is a systems problem, and the receiver is the component that's not been specified in this system. One other thing I'd like to say, I think we've seen many instances now, both at the FCC and NTIA, where this systems approach has looked at a problem and solved it. Sometimes it has to do with changing transmit characteristics, sometimes receiver, sometimes both. There are so many examples of it, and it happens constantly. So this is not new in that regard. We understand how to resolve these things. It's going to get harder, right? Dynamic spectrum is not an easier thing. It's going to complicate matters, but it's inevitable and it's needed. I think where this becomes very interesting in terms of services that the Commission and NTIA regulate has to do with ubiquitous services. Services where it's not at all clear how, after the fact or post hoc, mechanisms can address the concerns. And that's going to be something I think we need to talk about going forward. Evan?
Thank you, Doug. Evan?
Well, I just want to follow up on what Dale said and his summary, and disagree with him on a number of points. and
off to a good start.
Right. Well, but that's okay, because I also want to disagree with Pierre and also disagree with Dennis. So I mean, it's
equal opportunity.
It's equal opportunity. But I mean, I do agree, with the basic point, we need to do something. But let's just take that as given, and let me just quickly go through some of the points. One, assuming that we do have a interference environment, Dale raised the question of who defines the interference environment, And I think for the serious cases that we face, the problematic cases, it's got to be the government. These multi-stakeholder committees, it's not going to solve the light squared problem, the WCS DARS. I just don't see that. There's a really important place for those groups. 3GPP, they do great things, but they're not going to solve those fundamental conflicts. The second issue, which I don't think anybody except John and I actually came up with a specific proposal, is how you define the interference environment. What it is, and John and I at least have a straw man, which says you got to be able to operate in an environment like with cellular architecture, like a mobile broadband data system. and the other proposals, it's like, well, the standard is left as an exercise to the reader. But at least we have something based on what we think the highest value use, and then we can argue about it, but it's specific. The third point is, well, how do you regulate power? And this is where, Pierre and I and John Williams disagree with. When I say I, it's really John Williams. I think Pierre's approach in principle is more flexible. With this power at the ground, power flux density. But I think the current system of regulating power at the transmitter is relatively simple. It makes life for the people operating transmitters simple. They know what they've got to do and whether they've met it. It deals with the most difficult cases of interference, which is like mobile to mobile, very close distances where it is the power of the mobile units as opposed to some broad definition. So I think while Pierre's approach is much more elegant, I think there's something to be said about sticking with our current system there. Then there's a question of legacy systems. Pierre approach definitely could be extended, but he only did mention what do you do with new allocations. There aren't too many of them. We have to discuss that. But the really hard cases is what do you do about legacy systems, which brings us into the next point, which is the transition. How you deal with the transition. We haven't solved it, but at least we said something about it. And finally, I think there's the biggest issue with any of these proposals for establishing an interference environment is enforcement. And I do think that you may need some kind of, as I said in the slides, some kind of system certification or receiver labeling or something. So if somebody says, well, I'm going to deal with it by just accepting interference, well, you better have a big label on the devices that say, after this point, you're on your own, buddy. And it's sort of like cigarette pack labelings, not the small print that nobody can read. So those are my points. So I think I've managed to disagree with everyone.
I want a chance to rebut, but I won't insert my role here. We'll just go right on down the line. Dennis?
All right, I will keep this very short. You've heard from me more than enough in this session, but just the obvious, it is the time to act is now on receivers. We have spent a lot of time focused on transmitters. The time to act on receivers is now. It's now, as we've seen, not only in existing systems, but as we move, as Doug has described, into the world of dynamic sharing, dynamic spectrum access kinds of devices, the need that we experience now will become much, much bigger. To put this into a more easily digestible picture, the notion is that you have to have the size, shape of all of the pieces to the puzzle if you're going to play the game. All the game pieces must be understood, and receivers right now are not understood when you're playing the game of putting together the systems. So we've got to have the receivers well understood, well instantiated. In my mind, the multi-stakeholder standardization is an optimal way to put together those standards. Not all systems have the opportunity to use the multi-stakeholder approach, as Evan has suggested. So in those cases, it can be a single vendor or a small number of vendors that put together the standards. But there have to be standards for all receivers in the future. And therein comes the part of regulation. In my mind, I don't look to the NTIA or FCC to provide the standards, but rather to require that they exist. And I think that's the way that this can work, so that you do have the vendors out there, the innovators creating the new and exciting devices and creating the standards that go with those devices, especially the new dynamic devices that have the flexibility associated with them. But the role of FCC and NTIA is to ensure that those proper standards are in place. So that's key. Pierre.
So I'd like to do three things. First is to actually address a question that John suggested we answer on our previous panel, John Williams, which we didn't do, which was, so what problem is it that you're actually solving, Pierre? The second is to address some of the comments made by my esteemed colleagues here on the right. And then third, to just mention two things that I heard yesterday that really intrigued me and surprised me, and they may be crazy, they may not be crazy enough. So first, in terms of what's the problem, I think the way I would characterize it is to say that we're moving into a world where there is much more dynamic, tight assignment of radio operation. And the question is, how do you optimize such a dynamic system? So everybody knows we're going to be sharing. The second is a corollary of that there are more and more players doing wireless, and they are more and more diverse. And it's clear that the FCC is already struggling to resolve disputes. It takes a long time, even with the situation we have now. So that's not tenable going forward. How do we solve that going forward? Third, I believe there is a lack of clear definitions. We heard that a number of times yesterday. There's a lack of a definition of what harmful interference means. And there's a lack of a definition of what the signal environment is. And last but not least, because it takes two to tango, we really do need to address this asymmetry in how the regulator looks at receivers and transmitters. So I would contend that the solution in general is clearer operating rights. And in fact, the receiver interference limits is part of that. And the way in which you use that is it delegates more of these optimizations, both within a system and across boundaries, to the players. It's not always going to work. There are always going to be hard cases that the FCC will have to deal with, but try and offload as many as possible of the more mundane ones, the way that the cellular players already solve almost all their problems amongst themselves. How do we get the same mechanism like that across allocation boundaries? So now to address some of Evan's points and a point that Dennis made, as far as defining power, defining EIRP versus defining power on the ground, yes, I think it's definitely simple to define what the EIRP on a tower is. I'd contend that that's looking for keys under a lamppost. The light's very bright there, but that's not where your problem is. The problem, as we all know, is that interference is out there in the world. It's not at the antenna. So how do you give everybody a characterization of what the world looks like out there? Now, defining field strengths everywhere is one approach. There is another approach, which is you start with EIRP and you actually specify down tilt and antenna locations for everybody, everywhere. And when they move, they have to disclose that. That's another way of doing it. But if you want to look for the keys where it's dark, you're going to have to do that. The other interesting point was the transition. How do we deal with legacy cases? Dale mentioned this briefly as well. I think that I would hope in many cases the negotiation of, paying somebody to improve the quality of their receivers will just happen because rights are clear. And we actually saw that yesterday in one of the cases, the BAS versus AWS. It was clear that T-Mobile had to make the electronic news gathering services whole. And so they paid for the receivers and they upgraded the receivers. So that was clear. I think that interference limits give the regulator a way to say, in those cases where the market won't work, here's the interference you have to deal with now. 10 years from now, it's going to be up by 10 dBs. And 10 years after that, it's going to be up by another 10 dBs, without, in fact, predicting what the technology has to be and how you solve that. Dennis made this point about requiring that the FCC shouldn't set standards, but should make sure that standards are required. And I'm nervous about that because standards are always backwards looking. And as I look at what happens in 802.11 and ITF, the way I understand it is there are always standards evolving, and people will sell equipment that meets some standards, but not all of them. And so there are always going to be devices that are always not standards compliant. And I'm not sure how one deals with that. And I'm not even sure one should. Last point, the interesting ideas. The first was Carl Nebier's suggestion in his talk right at the beginning of Monday, which is that perhaps there should be a requirement on receivers to create a registry of their characteristics, so we actually know what the receiver characteristics are. You might even add to that, where are the fixed receivers? The other idea that I thought was sort of interesting was this notion, and everybody will remember which conversation this came up in, which is if there is a proceeding that is proposing to change the transmission permissions of one player and the receivers concerned do not object during the public process, that therefore afterwards when the rules get established, they lose their right to claim harmful interference as a result of that. Thank you.
Steve?
All I can say is I'm happy to be speaking after Evan, so he can't just disagree with me right off the bat. I didn't know this was going to be such a feisty panel.
Oh, yeah.
This is good, and I agree with a lot of the sentiment from everybody that this is a necessary topic to look at, and it's ripe for action. In fact, I think it's overripe for action. This is something that I think has been heating up as we've seen issue after issue where receivers and where there's been interference, and some of the cause of that is due to receiver performance. I actually agree with a lot of the discussion that defining the interference environment that you're expected to work in is the right way to go, to set some expectation that the incumbent has got to design a system, because it is a system problem, and it'll be a trade-off between receiver performance and the overall system design that goes into the solution of that problem. So defining that as clearly as possible, I think, is the right thing. And I thought the FCC actually went down this road when they did 800 megahertz rebanding, where there was interference between Nextel and public safety. And as part of that solution, they defined an interference environment. Part of the discussion was whether or not some of the public safety receivers performed as well as they should. And the FCC looked at kind of Class A receivers and as the top of the performance there. But they also, in defining rules going forward, said, okay, public safety, you've got to design your system to live with a certain power flux density, and if you receive interference at a lower PFD than that, then it's your problem. You've got to resolve that. You've got to fix that on your own. And if you receive it in a higher field, then it'll be the interferer that needs to resolve it. So I think that was the first step towards that, and I guess I'm actually been surprised that there hasn't been a little bit more progress in implementing that in other areas as we've looked at other systems. A lot of good discussion about the impact of decoupled receivers here, and I think there are different approaches that you need to take for different situations, and you have to look at where incumbents or new entrants have incentives to resolve problems or to manage the receiver environment. And I think that standards bodies, we should be relying on standards bodies to set the overall performance of the system. They do a good job of it. In the cellular community, there's a lot of discussion about how to make the systems perform in a given environment. But it is also a snapshot look at what's going on at that time, right? I mean, we kind of know what our neighbors are going to be, cellular systems on both sides of us, and what we have to do for that interference. Outside of the band, we look at what the neighbor is at any particular time. So, even there, you're not going to take into account the potential for a radar that doesn't exist yet or some other use that doesn't yet exist. So if we want that to be part of it, I think there is a role by the FCC and NTIA in helping to define the expectations around that so that the standards bodies can work that into their analysis. The decoupled receivers are a whole different matter where they don't necessarily have the same incentives to design to a high performance level or a certain standard, and they can sell a standard. I mean, in the cellular area, the carriers are going to. We work with the manufacturers, and we essentially would be enforcing the standards, right? We're in the standards bodies, working with them to develop it, and then we require that our equipment meets those standards. In something like the broadcast community, the broadcasters have no way to put those requirements on a television receiver. So I think in that case, FCC regulation and requirements that standards meet a certain or receivers meet a certain standard is probably appropriate. And then on the government side, it is good. I'm glad to see NTIA involved in this in the discussion because it really is an issue that's got to be solved between government and non-government entities. But I think we need to look for incentives on the government side or to help ensure that from the time that those systems are designed, they're designed with some sharing in mind or some immunity to interference. And again, some of the same approaches can work of defining the interference environment that they're going to have to work with. But I think also if we can work in specifications that incentivize mechanisms for sharing would be an important part of doing that. More and more we're looking at how do we share with in radar bands. And there was the session out in Boulder last year. There was a lot of good discussion about radar systems, the design of radar systems, and a lot of the guys out there that are involved in the design of radar systems said there was no technical hurdles to what we were talking about doing, but none of the specifications require that it be part of the system design. So getting that into the spec up front, and nobody's going to add it without it being part of the specification because it'll just add cost regardless of how little it is or whether it's much of a burden. Nobody's going to do it unless it's part of that specification. So I think that's another area where probably FCC and NTIA could work together to help drive some requirements that future designs include that as part of the requirements. I think that's probably my comments for now. Thanks.
Larry. Thank you. I think Steve just touched on a very good point, and that is that while much of the interference issues we've been dealing with and talking about the last couple of days have been between commercial systems, as we look to better use the spectrum, we're going to be dealing with, I think, more potential interference issues between federal or governmental uses and commercial uses. I'm not sure which of the models that were talked about today might be the best for dealing with that, but I think that is something we're going to have to look at more and more in order to make the most effective use of spectrum. And while I wasn't at that session, the fact that there appeared to be no technical barrier to doing what you were talking about, then says what it really is how do you figure out how to do it and what's everybody's role. I also think that another good point was made was in the 800 proceeding. The commission, the focus of most people has been on, okay, you're moving everybody around, but I think what may not have gotten as much attention, and I did mention it yesterday, however, was the fact the commission did basically establish what the interference framework would look like in the 800 megahertz band and put obligations on all parties to operate systems that have a reasonable chance of working effectively in that environment. If you don't do that, you don't get protection. If you do that, then you do get protection. And another point is during the interim, during the transition, the approach is something like what Pierre was talking about in terms of if you experience interference, then everybody who is within a certain radius of the site of interference, whether it's a commercial carrier, Nextel or AT&T or Verizon, if you're within a range of that location, you have to then be involved in testing to identify where's the interference coming from. And interestingly, it isn't always what you expect. Sometimes it's been the cellular carriers as opposed to Nextel, now Sprint. Sometimes it's been a combination. Sometimes it's a bad BDA that nobody knew about. Or a repeater that's broken down somewhere in a private building. So, as you're transitioning from one approach to another, at least that approach of looking what is happening at the site where there's interference probably makes a lot of sense. But on a higher level, I think, I'm on this panel for the carrier viewpoint, and I think I certainly agree that it's time to move forward on this subject. And whether it's through specific rules or performance objectives or the approach that Evan has laid out, I think it is time to move forward. The carrier's concern predominantly is how do I serve the customer and give them what they need? And a carrier at the end of the day is looking to set up its system to provide the best possible experience to the customer. And in a competitive environment, you're constantly trying to up your performance. So that means using the spectrum more and more intensively. So I think there's no question that going down this path and dealing with receiver performance and not just transmitter performance is certainly what needs to happen going forward. And finally, I think at the end of the day, as I said yesterday, I think this is the FCC's ultimate responsibility. If you can do it through multi-party discussions and negotiations and setting standards, that's great. But at the end of the day, I think there are cases where the FCC will have to be involved. It is the basic purpose of wireless regulation. But having said that, in the auto safety area, the National Highway Traffic Safety Administration sets out motor vehicle standards or safety standards in which it specifies the performance required, but not how you get there, not how you do it, and leaves it to the manufacturers to find different innovative ways to do it. And we've seen different manufacturers get to emissions control, mileage under the CAFE standards, seat belts versus airbags or combinations, strength of wheels, a variety of different things through different ways of doing it. And certainly I think there's some illustrative thoughts there that while the government can say this is how we want it to perform in a defined environment, you want to allow maximum ability for innovation and diversity in getting there. Thanks.
Thank you. Penny? I wanted to just add a few kind of observation. I'm relatively new to this particular field, but I've been working more in kind of more software-defined systems as opposed to systems at the physical layer. And a few things struck me. One of those is that we've been trying to talk about kind of limits as to thresholds, power limits, and so on. But if we look at many of the modern systems, we're moving from a circuit-switched, defined performance world into a best effort world, where if you look at all modern data systems, they don't have a fixed performance. They have a range of performances, depending on the environment, the load, whatever people are doing. That has the advantage that you can optimize. You don't have to you don't get the guaranteed performance in all cases, but on average you get a better performance than if you just got the minimum that you can always get. It may well be instructive to look at that in the spectrum environment. OFDM and other techniques are already heading in that way, where it is not, in most modern systems, a cliff effect if you design it well. It is a gradual degradation of throughput. And it may well be that a better characterization, not just of the thresholds, but of the environment, both in space, time, power, interference, activity levels, might be helpful for new entrants to gauge whether this is a desirable environment to work in. We do, however, have, I think, two technology trends in our favor. We no longer have dumb receivers that simply receive and render a picture. We have now mostly receivers, again, legacy accepted, that are available also as measurement and diagnostics devices. So we have now millions, hundreds of millions of devices that can measure spectrum, that can measure their performance if they don't exactly leak other information, as a recent incident indicated, to the carrier. And we can use that to get a better sense of what is possible and what we can do in this environment that strikes a good balance between setting limits so high or so low, depending on how you look at it, that they restrict what is feasible beyond what is really necessary. So we should, I believe, operate in an environment where we simply assume that performance is going to vary. It is not going to be always a fixed rate. The other one, which I think is an important one, we are now operating in an environment of software of in-the-field upgrades. We just assume that our devices are upgradable. Maybe that needs to be part of a design on a much broader scale. To me, it seems like we're working in two environments. We have really cheap devices, which are essentially throwaway devices, where every nickel counts, and but the assumption is if it doesn't work, you buy a new one, the $20 type devices. But anything beyond that, there has to be an expectation that these devices are upgradable in the field. We wish, I suspect, many of us, that as we did ATSC, that we could make these TV sets upgradable so that we could get a new TV codec, for example, when we have MPEG-4 as opposed to MPEG-2. We probably wish for many GPS devices that they had field replaceable filters that they could use, or other other measures that would help to ameliorate performance that is just very hard to predict ahead of time without setting overly stringent performance characteristics. That may well have to be part of a discussion of a systems design beyond just simply assuming that these are static and then throw away. As we increasingly get in a software environment, that becomes, I think, part of the environment. Maybe that if you can show that you can upgrade your system, maybe the requirements that you can meet or need to meet initially are lower simply because you promise that if the time comes, if a necessity arises, you're willing to do the upgrades later. The other one, which I think item point that I think has been received only occasional mention is the consumer aspect here. Right now we're talking mainly because of vendors from a consumer perspective, from a manufacturer perspective, but the poor consumer really has no way of judging whether they're buying a robust system of any sort and are willing to spend a few extra dollars because they intend to keep that system for quite a number of years, or whether they got a system such as certain satellite radios, which work just fine as long as the environment doesn't change. Amazon reviews aren't going to reveal that because the environment that's going to exist 2 years from now, 5 years from now, is not reviewable. That is, I think, where some organizations, the Wi-Fi Forum, for example, could do a lot better job of simply providing better consumer education so that if you buy a El Cheapo device, you know what you're getting yourself into. That may well be a good consumer trade-off, but you know you run a risk that it's going to run out over. A final one, since we have a number of university-related people here on the panel, is one thing that has struck me is that the surprise factor. Again and again, we've been surprised after the fact with things that we might have been better at predicting if there had been third parties that don't have a direct stake in the negotiations or don't necessarily have an advantage of hiding things with the intent possibly that they will then only become apparent once they can no longer be easily fixed, kind of the facts on the ground. That maybe we can find ways to earlier engage both NTIA and FCC technical capabilities, as well as outside parties such as university, in investigating those situations before they occur, hopefully with people who don't necessarily have a direct financial stake. I find, for example, it somewhat frustrating that while the FCC has lab facilities to evaluate commercial products after everything has been written down, we have very little lab facility, lab capacity to do kind of more free-form exploratory investigations. We always have to rely on the filings that we get. And having been here just a few months, I can generally classify those into can't be done, won't do, or you can't make me, and those are only those are of somewhat limited usability.
Dean?
Oh, gee, Heading, you sound like a real FCC veteran after only a couple months. Well, first off, I think this has been an excellent 2-day workshop, and kudos to the Commission for organizing it and OET, and thank you for including Qualcomm, my colleague Gene Fung yesterday, and now me today. So I just have a couple comments, mostly because it's so delicious to watch Evan, Dennis, Pierre, and Dale go at it. And, of course, it's March Madness, and Evan has a tremendous home court advantage. So just a couple quick points are, one, at Qualcomm in the cellular world, we are always designing an overall system. So we're designing the receiver and the transmitter to an excruciating level of detail and specified almost ad nauseum. And as Steve was saying, and I think it was alluded to in other panels, there really is, the system really functions extremely well. If we test our devices with our chips to an incredible level, and then the operators do, the OEMs do, and if we're not meeting the spec, Steve's company and Larry's are going to stop buying devices with our chips. And in fact, if someone else comes along and beats the spec better than we do, then that's going to hurt us too. So I think whatever the Commission does or doesn't do in the cellular world, I think we're, if I can be so bold as to say, we're a bit of the teacher's pet here. I don't think there's any need to replicate 3GPP or in any way impose any new regulation on what we're doing. Now, I will say I can think of 5 systems that Qualcomm designed, and in each case we looked, again, exhaustively at the adjacent bands, the services that are going on, and of course we're always at an advantage because in the systems that we design, we control the transmitter design and we control the receiver design, and then we meaning once it goes through the standards process, the whole industry, and of course the carriers sell the receivers and they won't authorize the sale of a receiver to come onto their network if it doesn't meet the spec. I think a lot of these systems that have had a lot of these issues, such as the ones we heard about yesterday, come into play where the same party doesn't operate the transmitter and sell the receiver, spec the receiver. So I don't know. I'm not an economist. I don't know whether you how the economists would characterize that problem, but that's certainly, I think, a large part of the problem. And then another point I want to make is, and this will be maybe a slight quibble with Evan. I'll do that at my own peril, I'm sure. But the standard is never no interference. Even in today's first-in-time regime, there is always, in every service I can think of, there is a de minimis level of interference. In the TV world, in analog, it actually used to be 2%. Today, I think in digital, it's 0.5%. In the LightSquare GPS fight, it was 1 dB, right? Under 1 dB is considered, just you're going to have to tolerate that. So the standard can't be zero interference in any system. Otherwise, we'll never have anything new come along. The problem, I think, is defining what the level is, and then enforcing whatever the rule is. So then my last comment is, to Pierre's suggestions, a lot of which are based on the spectrum usage rights in the UK that William Webb was so instrumental in. I guess I have to make this confession. So they have this regime of spectrum usage rights, which are actually, by the way, the Commission in Part 27, we have field strength limits at the boundaries. We don't have a system of modeling. We don't try to measure it throughout, and there are lots of reasons for that. It's hard. But my confession is this. So in the UK, they only have the spectrum usage rights in one band, which is the 1.4 band, and that band is channelized in 1.7 megahertz channels. for the most part. So really, really narrow channels. And so I was sent over to England to buy some of that spectrum from Qualcomm, and my only conclusion was the way to have 100% certainty and 100% spectrum usage rights was to buy 100% of the spectrum. That's not a solution to this problem either. So we have to have some, and I think a lot of these problems are so unique, band to band, service to service. But I think the ideas that have been expressed today, I think, are all worthy of consideration and are all all need to be studied. Thank you.
Yes, thank you very much. And it's an honor to be on such an august panel as this. Thank you very much. I do have a statement to read. My Washington, D.C. colleagues have suggested I just point out, I am not now, nor have I ever been, a lawyer. And I'll also add that I am not a bona fide spokesman for my company when it comes to policy issues. I am instead an engineer. And I'll try and speak to some of those points and try and hold the reins on some of my political leanings here that we will probably leak out at the very end. We are, of course, always tempted to solve the last problem in the same way that generals fight the last war. This presents a number of difficulties, and as an engineer, let me just point out a few problems with the fence analogy. Good fences make good neighbors has been recited here many times. There's many things to say about that. One is that there are cases, and I had a view graph in my presentation yesterday, the last one that I skipped over for time purposes, but it's worth reminding ourselves, as some of you are aware, in a discontinuous time system, there's like GSM when it first came out, there were lots of hearing aids and speakerphones and things like this that were getting interference picked up. To this day, if you put a GSM phone near some brands of speakerphones, you can hear the paging signals. And it's worse than that. It can cause interference into adjacent TV, digital television standards, particularly we've seen this in Europe. If there's an even order intermod product, it becomes a power detector and can cause interference. Unless you add idle noise to the idle time slots, in which case the envelope detection that's going on in the receiver tends to not leave saturation, or it doesn't jump up and down in the AGC circuit. And so let me be clear. You can add additional power to the interferer and reduce the interference. So let us be careful about unintended consequences here. If we try to regulate or specify certain things, we may be unintentionally hurting the ability to solve some interference problems. There are not many examples like that, but I thought it was worth sobering ourselves with these sorts of observations. There are, of course, many other ideas for how to improve spectrum usage. I loved Henning, your comments in particular, and a number of other comments about dynamic spectrum usage and some of the concepts that we see with light or white space and having a central database. That it is indeed true that many of our things that have been receivers only in the past are now becoming smartphones. And if you turn on your GPS, you ask for your location here in this building with a metal roof over us, you will still be able to find out where you are through this two-way communication that the smart receivers are able to provide us nowadays. There are many more modes of operation, many more redundancies in the system that allows you to find your location in this building on your smartphone without the satellite signal, because it's interfered with or you're blocked by the screening, because it's using the MMSI ID and the cell IDs that it's able to pick up through other channels on other frequencies and other standards. So we do indeed see a lot of potential for smart receivers in the future, having two-way communications on other channels with redundancy that can sort of solve the problems through brute force and other using other methods instead of just dealing with the particular interference at a particular site on a particular frequency at a particular time. Unfortunately, there are many other products that are not like that, and they're not all just legacy. I myself have made some very wideband receivers for about 60, 70 cents that went into an RFID system. The shelf tag price display on grocery market shelves. And these receivers had very wideband receivers and very poor ones, too, maybe minus 60 dBm is all that their sensitivity was. But that was adequate for the application. And so we also have to be careful not to introduce regulations to solve a particular regulatory problem that inhibits innovation or other kinds of applications that we may not be conceiving of right now. We're all smart people here. I'm sure that we all know that there's certain bands where you can do certain things and other bands where there's loss of life issues that where we put more protections. But and there's different solutions to the regulatory regime in these different areas that inevitably we would work ourselves to. I do want to think, though, a little bit more about some of these other systems and legacy systems, and how do we get people to vacate, or how do we decommission a system? You know, the HDTV and the analog television and TSC switchover was a remarkable case, but it's a particularly bulky case. There are many smaller cases where we need to think about if there's 1 million receivers in a band, and they've learned to spread out their receive band in a way that gives them millimeter accuracy or whatever, they do indeed incur certain squatters' rights. And what do we do about or at least they have the right to be at the negotiating table. They may not have a right to somebody else's property, but we need to think clearly about what is the nature of the squatters' rights, and how do we incent designers and the industry from encouraging growing the receive band in a way that incurs these squatters' rights without intention or without visibility. I think an important way that some of you, Evan and others, have been stressing is the importance of visibility and transparency and the ability of one new service provider to be able to come in and understand what is the nature of the existing regime of receivers out there. But of course, they can only find out what the existing receivers are, not the future receivers. And in some ways, in fact, this problem, and I was hearing something yesterday about the opacity or the opaqueness of the receivers from the point of view of some of these transmitters, the manufacturers of the transmitters or the service providers. Trying to introduce transmitters in an adjacent band. And this is very similar to a problem I've seen in other cases of patent infringement, where a company and an idea and a new business model is contingent upon knowing that they can deploy a system when there may in fact be a patent in the application process that is not public yet and is a landmine to their business case. These things happen already. And maybe what we're seeing here is that the craziness and the difficulties and the frustrations in the patent regime is something we're seeing now acting out in the FCC regimes. Let me finally state, I've got one more statement. We've been talking a lot about this fence analogy and how if we set the fence high enough, we can keep the transmitters from getting over. And if we put the fence down close to the ground so that the receiver sensitivity doesn't leak out from underneath it and swell up and disturb the fence from the bottom side. And we worry about the placement of the fence. And we sometimes even misquote who gave us the line, good fences make good neighbors. I encourage everyone to pull out their iPads or their smartphones and look up Robert Frost Mending Wall. It is a tale about hubris and being stupidly following traditions. It is not about how to make good neighbors. Something there is that doesn't love a wall, that sends the frozen ground swell up under it and spills the upper boulders in the sun. And at the end, he says, bringing a stone grasped firmly by the top in each hand like an old stone savage armed. He moves in darkness, as it seems to me, not of woods only and the shade of trees. He will go behind his father's saying, and he likes having thought of it so well, he says again, good fences make good neighbors. But let's be aware, that's his neighbor that says that. He is inspired by the spring. Thank you.
Thanks so much, Steve. What I thought we'd do now is briefly allow a little bit of interaction among the panelists, but I'm sitting here literally with some 20 questions, so I'm a little bit overwhelmed, and I will apologize in advance when we get to these questions, and I'm not going to get, obviously, to all of them, and I'll try to be as even-handed as I can in handing them out. I did want to respond to Evan, because I too would hate to I too would hate to leave here disagreeing with Evan, and let me clarify what I was saying. My experience with multi-stakeholder groups is, ultimately you're going to need some sort of a regulatory backup. There's no question. But what my experience is, if you get engineers in the room and they get in the problem-solving mode, often what you find is one engineer says, gee, if I give up a little bit of this, will you give up a little bit of that? And there is some negotiation across it. And my hope in multi-stakeholder groups is not to eliminate the need for the commission ultimately at all, but there's normative decisions that have to be made eventually, and those normative decisions are the decisions that really. But let us engineers try to get as far as we can before we have to turn to you to make, for example, some of those normative decisions. So I hope we're not quite as far apart, maybe, Evan, as you thought.
And if you are, Evan's wrong and you're right.
Shall we? Any reactions here before we turn it over the stack of questions? Sure, Dennis.
Yeah. Just a couple of reactions. One to my colleague Pierre, as he and others talked about this as well. So the reason I bring it back, this is this whole notion of standards and how they inhibit innovation. I think that's really an extreme misnomer, particularly for classically licensed systems. The great innovations that have occurred in the licensed systems do come on the shoulders of the standards process that moves forward. And I think cellular is probably the poster child for this, but the standards are way out in front of the implementation. And they really are leading things in a very, very nice way. On the other side, supporting Pierre is the unlicensed regime, where the new fanciful activities occur with things that have not been thought of before. So I think if we put that kind of notion in place, that standards and multi-party standards, multi-stakeholder standards are really very, very helpful in enhancing innovation and progress, whereas we do keep an unlicensed regime to allow for the very new ideas to come out. In that notion, there is an emerging idea that a lot of people have been talking about, and I'll throw it out here for this group to simply think about, And that is the notion of a three-tier structure for any spectrum. So there is a primary licensee for spectrum. There is a new secondary licensee for the spectrum, so that if the primary is not using the spectrum over an extended period of time, a secondary can come in and using a database or some other structure that would allow that to take place in a flawless and fluid manner. That would give an approach. If neither the primary nor the secondary are using the spectrum, that spectrum would become available for a tertiary or unlicensed user, and that would provide a playground for a lot of the new ideas. So that's a context for at least a lot of my own thinking. I'd like to do a here to something that Henning said as well, and this is the notion of what it is that we are dealing with, and it really is something that Pierre talked about as well. Our whole notion of what we're handling from a wireless standpoint is often cast in the context of the rearview mirror, the analog voice kind of environment, when the dominant amount, at least from a per bit standpoint, the dominant amount of information that's conveyed wirelessly now is data, and in fact packetized data with all sorts of structure around it that allows for parts of the data to be lost and still have the whole message conveyed. So I think we need to make sure that we have that also in our heads as we're thinking about these things.
Other reactions, Doug?
So I'll put on my NTIA hat. I think it's very important, though, and as much as a lover of interference-tolerant design and software-defined radio and everything else, that when we say that, we are very much in a comms perspective. And it's not to say that radar and other services aren't evolving and taking advantage of some of these things, but it is a very comms perspective. And again, the conference we held last year in Boulder at ISART, we looked at some of these issues and how they might play. But there are areas where, again, interference tolerance is not yet evolved, and I agree with Brenner that it's always been there. We've always tolerated some kind of interference, but in certain services it's much more difficult, and radar is one of those.
Any other comments from up here before I turn to the Henning?
I would disagree with the statement, except to say that we're less likely to add more bands in those services. The number of radar bands or GPS bands or GNS band is probably what it is now, so we have to deal with those, but they're not as likely to be added in the future as data bands. That seems to be at least the current prediction.
I think the radar community would push back on that. What I think the better thing to say is, and the more accurate thing is, that the radars and the comms are going to have to look to live together, coexist in the future.
Yes.
There's a lot of radar bands that may be opportunities for comm bands in the future through some kind of sharing. That then gets to the need for NTIA and FCC to even further collaborate, and that's collaboration is already difficult, and in trying to now figure out whose receiver specification, some limit or whatever that might be, and how that all plays out. That's going to be an important part, and we've already had some experiences with that. We've had some NTIA and others working on some of those specifications, but that's going to be more and more of a thing, and as we now have some primary federal and some comm service coming in, broadband mobile, they will probably need something of a receiver specification to understand how to operate, so we don't have the garage door opener issue.
Why don't I go ahead and turn to some of the questions. And again, I apologize if I don't get to your question. I have to confess I have rejected one because I can't read it. But okay, regarding Evan's proposal, how would you deal with services that might not be able to sustain the proposed criteria and might be valued less than the criteria standard? an example, I think what they're saying is radio astronomy. In other words, you've got radio astronomy. How, from a public policy standpoint, if we take your highest value use as being a cellularized sort of commercial type network, how do you deal with it when the competing application might be radio astronomy?
Well, that's why we had some weasel words in there.
Oh, boy.
Yeah. No, I mean, yes. Like we said, new allocations must avoid encumbering adjacent bands targeted for flexible use. So, I mean, radio astronomy is not going to be, assuming it's not going to be targeted for flexible use, then it's not going to have to, tolerate that kind of environment. But, since you mentioned radio astronomy, I'll have to digress and talk about it because it's an issue with repurposing the UHF TV band. Channel 37 is now devoted for radio astronomy, and there's a possibility of moving it so that it. But there was an experience with radio astronomy in the UK where when Ofcom came to the radio astronomers and said, you're going to have to, I don't know, what they talked to them about how important the use was, and they said our use is extremely important. Then they put a very modest tax on them, and they decided they weren't really using it that much, and they went away. So I don't know, whether radio astronomy might be targeted for flexible use, but if something that's not, then it's not going to have to tolerate it.
But there's another sort of sub-question of that by a different person is, in what criteria have you used to establish in your mind that the cellular-like broadband application is the highest value use versus, let's say, UAVs or something like that?
I mean, you just look at the growth of mobile data. I mean,
these are my question, Evan.
and it's just growing at an astronomical rate. For the smartphones, the tablet devices, and so on. But again, on the weasel words on the issue, we raised the question as to. That was our second point, defining the most valuable use model that receivers must self-protect against. Is the dense deployment of base, mobile, and fixed transmitter likely to remain the most valuable use? I mean, that's an open question. But I think what's really important is to put down a marker and have something specific instead of just there ought to be some standard. I mean, I think you can make a plausible case that probably is the most valuable use, and that's what we should be aiming for. At least it's a point to start the discussion, as opposed to people, let's say, we're going to leave it to some, whatever multi-stakeholder group. They're not going to decide that. I mean, that's basically, something that the FCC has to decide, and you need that. It's just basically changing the default assumption. Right now, the default assumption is everything should stay the way it is. And I don't think that, I think we could at least argue that the current use is unlikely to be the most valuable use. And I think, that these cellularized systems are certainly a plausible candidate, but it's sort of open for discussion.
So I'm going to argue against this. You said that the FCC should be the one who decides the most valuable use. The FCC has a certain perspective on the non-federal side. I can understand the role of government here, and that government might be the one to decide the most valuable use. But I don't think it's within this building that hierarchy should be established. Clearly, there are federal applications that are very valuable that, again, your tax model, while it's interesting and humorous, the radio astronomy groups don't have the money to pay the tax. That's why they can't pay the tax. They don't have a means of paying it. And there's some work being done currently looking at, are there mechanisms of providing funds to federal agencies and other users that could then be used to create that market so that the value could be ascribed to the spectrum that they hold, and that they could then use that spectrum, either keep it, use it more efficiently, justify it. But again, there's a lot of valuable uses of the spectrum that are outside of this building.
We're not talking about this for federal spectrum, and I said there's a qualification to it. But I think just on the federal side, I think there should be a presumption in many cases that the federal users have to be able to coexist adjacent to something that looks like this. We're not telling, and when I say most valuable use, we're talking about flexible use. You can do anything you want. If you look at the PCS allocation, it doesn't say you have to have mobile services. It's allocated for fixed and mobile use. It's very flexible in what you can do with it, and that's what I'm talking about. But it allows for a cellular architecture, with mobile units. But it's not like the government is deciding what the use is. And as far as the federal, that's not. We're not talking about. We're not talking about this really applying to federal users, although it may. You may be able to extend it to some degree that federal users might have to be able to operate adjacent to something like this. But really, this is focused, on commercial spectrum under the FCC jurisdiction.
So not shared use? Because most spectrum is shared, right, under 3 gigs?
I think there are two somewhat separate issues. Namely, if you have scarce spectrum, how do you allocate it, and how do you value spectrum? And I think Doug alluded to this. And Evans, I think, is a slightly different question. Namely, if you don't know what the neighbor is going to do, by definition, that's the problem that we're facing. We have an allocation, and we know we're going to change something, but we don't, by definition, don't know who we're going to put there. I think his, if I understand it correctly, is kind of a default presumption that the current most valuable use, namely the new use we would in an economically efficient system put this spectrum to in the future, would at the moment be that type of usage. That does not mean that is a decision that decides that this is actually going to happen, but that's the most kind of the safe default assumption that you would assume that would be the most likely to interfere because of the highest density, because it's really, I think, in some sense, not so much about value in a financial sense, but also of a bit density model. Given in a spectrum scarce environment, in a comms space, again, ignoring radar and other non-comms application for a moment, is I think the general notion is we want to design systems that on a societal scale have the highest bit areal density, if you like. And that, I think, is a different way of also saying that those tend to be cellular, mobile, and high transmitter density system with modest power in each one of those. And so I think that's probably a slightly more engineering way of saying the same thing, which also tends to impose the highest requirements simply because you cannot rely on very weak, very far away transmitters or a very sparse number of transmitters, since we know that the bit density just by Shannon isn't going to be as large as if you have dense transmitters. Does that? I mean, I don't want to. I think the danger is of conflating making choices about band uses versus trying to predict unknown neighbor usage, which is, I think, what Evan is trying to do.
I agree totally with Henning.
But the thing is, again,
because I would say it also is a good thing for the federal side to look at too, because we operate adjacent to federal bands as well.
Exactly.
So as you look at these kind of impacts, and it can help the federal users design systems to take that into. Yeah, okay.
It's lessons learned into that federal, because the federals are going to be adjacent as well.
I'm getting a little nervous here. We've got two questions. There's 22, so let me just, if you would, try to see if we can get through a couple more questions. Just Pierre, one of your arguments against standards is the complexity, but by analogy, the LTE handset spec has 30 pages on the transmitter, while the FCC limits only ERP and OOBE, in other words, out of band. Why can't the same approach be used for receivers?
The reason, I think that's a question I've been asking as well, because when one talks about device performance requirements, what is often said is, well, we'll just have minimal ones. And I keep asking for examples of what such a minimal spec might look like, and I still haven't found one. So, for example, in the rules, I found the FCC rules for, in this case, it's cable receivers, and it's a very long list of parameters. The NTIA 2003 report on receiver standards gives a table of generic standard. This is what a generic standard might look like. And this, by standard, they mean device requirements. And I can't remember what all the parameters were, but there were about 7 of those. And so those were just the figures of merit dB of attenuation, and they didn't specify what the test signal was against which you have to measure that, and the quality of service that it would have to meet given the test signal and the attenuation. So my answer to that point would be, I'd love it if there were minimal receiver requirements. I just haven't seen them yet.
Any other? Okay, let me turn to the next question. How should regulatory bodies in the U.S., Europe, and Asia, and industry standard organizations interact, collaborate, or explicitly divide their roles and responsibilities? How could more involvement, interaction with standards organizations by technical representatives of the regulators, especially in the U.S., be helpful or not helpful? Anyone want to tackle that? Steve, you look like you're leaning forward.
Yeah, okay. I was just going to get a drink of water. I think the regulators have to set an environment and then let the standards bodies build and work around that, and design a system that performs with that environment. I do think it's appropriate for the regulators to monitor what's going on in the standards so that they're aware of what direction the industry is going in, and how things are being developed, and if there are issues that they flag, that's certainly appropriate to take into account. But I would be wary about having the regulators too deeply enmeshed in that process itself. Again, I think it's the regulators' role is let's set the basic parameters of this that needs to be taken into account, and I think that environment of what kind of interference environment do you need to operate in, and then let us figure out the right way to solve that problem. And I think some of the comments before about not being overly prescriptive is a good one. There are different ways and changing ways to solve these problems.
In my own mind, it seems that the government, wise to stay as far as away it can from sort of that internal optimization within the sort of industry sector. But what the difficult problem here is this adjacent band problem, and and I'm not contradicting what you're at all. There's where the government could say, "Hey, be careful, because there's something over here, maybe that's classified or something that may really cause you problems, and you need to be thinking about that." So, I think we're in agreement. Any other comments on that?
Just a quick one. Actually, I already addressed this one, but I would to say it more succinctly. I view the regulatory role as more of a quality assurance role. The standardization actually have the implementation role, and it's quality assurance, especially for things like you just mentioned, for areas that are beyond the scope of the standardization body, to make sure that at the edges there is that quality assurance coverage.
We've got to keep reminding ourselves, to me, this is primarily an edge an edge problem. Yeah.
One of the having worked in standardization, one of the difficulties is that it tends to be industry specific. You get the people who are interested, and so they're either not aware or that's very low on their priority list of what's going on elsewhere. We heard variations of that yesterday in one of the motivating cases, shall we say, here, where I think regulators have an advantage is that they often see many different things that no single industry can be aware of. And so I do see a role as essentially kind of as a representative of the public interest in simply making the engineering side aware of a larger world out there, because I know most comms engineers, like Doug pointed out, are probably not generally aware of the radar side. It's not their culture. And you can give, the GPS example is obviously has been cited many times. So I do see a role, whether this is government or simply the liaison model, which some standardization bodies have, where they explicitly invite people from other standards bodies to be observers and possibly kind of their dragons here, as you mentioned, type of participants.
Okay, Evan, in your proposal, one...
It's John's proposal, too.
Can we turn around and ask questions to the audience? Yeah. In your proposal, one does not know if self-protection is adequate until the new adjacent use is deployed, while a receiver standard can be tested immediately. How do you address, and this is sort of the general question I would also, how do you address the enforcement testing compliance in your proposal?
Okay. One, the disclaimer, I'm not an engineer, but just on the first part of the question, you can have whatever receiver standard you want, and that's no guarantee that it's going to operate well within the environment that you find adjacent to you. So, I don't see, yes, you can do the testing on the bench and make sure that the receiver meets the standard, but what does that do you if it doesn't work? So I don't get the point of, that you can be sure that it meets the test bench standard, why that's an advantage. Now, the broader issue of enforcement, our whole notion here is self-protection. So when the system's built and you find it, and the system adjacent to you is operating totally within its requirements. It's doing everything that it's supposed to be doing, no violation of anything. If your system doesn't work, that's your problem. Now, there's an enforcement issue when they come to Congress or the FCC. But our notion is that that's your problem and you deal with it. And how you deal with it are multiple things. You could have an internal guard band. You could try try to do something with your receivers. You can accept additional interference. You cannot operate in certain areas. But our notion is that's up to you. And if it's like if you miscalculated, that's your problem.
Reactions, Pierre?
Yeah, I think this enforcement issue is a very important one, and something which I'm sure I can't, and maybe not even this group can do justice in the remaining 20 minutes. And in fact, it's something that Peter ten Hoele has thought a lot about, and we did a meeting at Silicon Flatirons. Just to make a distinction, I think there's before the fact enforcement and after the fact enforcement. Yeah. John and Evan's proposal and the approach that I'm advocating really are about, I believe, after the fact enforcement. If there turns out to be a problem, if you suffer harmful interference, then there's a determination of whose fault it is. And it's in fact very useful to be able to then know who has to bear the cost of fixing it. Because there's always a technology solution. The simplest technology solution is always there. One of the systems is switched off. You just need to know which system gets switched. Now, that's obviously a gross oversimplification. And I think for after the fact, perhaps where John and Evan and I diverge a little is I think for after the fact to work, you will have to describe what that flexible use system looks like in enough detail that somebody can in fact be told you needed to have known to fix this. And I think when one defines flexible use sufficiently well, we probably converge. We probably, in our two positions, get to something very close. But I think that before the fact enforcement is the decoupled receiver case and the unlicensed device case and the garage door opener case, where there is doubt that the receivers that are going to be deployed can be trusted to accommodate the interference environment, or if there is a problem that it will be clear that if it's their responsibility to fix it, that they will in fact fix it. And in those cases, you do need to do something ex ante, either through self-certification, maybe through labeling, maybe through mandatory standards.
Other comments?
Yeah, well, I think there's even for when you have a system operator, I think we might need some kind of system self-certification or receiver labeling. I mean, for example, this is a fundamental issue of how you make it credible that it's your problem, when the Commission has such a sterling record of resisting pleas of skilled lawyers. This is a compliment to many in the audience. But so, I don't know what the answer is, but I just talking to when John and I were discussing it, I could imagine that the FCC could require a system operator to have this certification plan which says what they're going to do. Now, one of their options is they can say, we're going to do nothing. We're just going to deal with it. And then I would say, if that's their option, that's where they better have those labels really big, on those, on their devices. It's fine, but we're going to have the picture of, you're dying from gum cancer or something. It'll, whatever. Make it really salient on those things. You chose to do that, fine, but don't leave the customers holding the bag. Now, I don't know if that's a practical solution. I think that if there's one really serious problem with this proposal, it is enforcement and having credibility that will actually do what we say, which is say it's your problem, as opposed to having 10 years of negotiation.
Any comments?
Evan. One quick comment.
Sure.
The question is, do we see the role of bodies like the FCC or Underwriters Laboratory just to ensure safety and non-interference, or is it also consumer protection? And namely, evaluating things. You could imagine, as part of the FCC, every device that we're concerned about here goes through the FCC labs, even garage door openers. And so you could imagine doing that, but you could also imagine that would be problematic, and so in a variety of ways. So the problem and the question is really also one, but much bigger one, do we increasingly see, given ever-increasing complexity of devices, the role of the FCC certification process in particular, as more than just simply ensure non-interference, do we also ensure that it is a minimally functional device, because given that most devices are no longer made by companies that you recognize or that are not going to be around a year from now, the recourse that a consumer has when they find out that the device is non-functional is essentially zero. The practical recourse for most devices.
I've just been handed a note here that we need to wrap up. This is sort of the 5-minute warning before we turn it back to Joey. There is a whole series of questions here regarding specifics of GPS, and let me ask a single question here that somebody sent in that may capture some of the rest. With no GPS people on today's panels, what have the panelists learned about GPS needs and opportunities?
I don't know whether we learned this, but I mean, it's undeniable. GPS is a very important service. It's important in cell phones. It's important in airplanes. It's important in all kinds of places. There are a large number of GPS receivers. I've actually asked, because I'm on the federal PNT advisory board, I've asked the agencies that run the GPS system if they know how many receivers there are out there, and the answer is they don't. There are obviously a zillion of them, whatever a zillion is, and it's obviously a very important service. But it obviously still, like every service, has to operate with folks on either side of it and subject to rules, and we have the rule of law, and I don't care to delve into the whole light squared issue, but that will obviously have to be decided. But in terms of how, there's no one on this panel from the GPS industry. Obviously, Qualcomm makes hundreds of millions of chips that have assisted GPS inside, and it's obviously a hugely important service.
Any other comments, Steve?
But it does go to that decoupled receiver issue and the need to look at what's going on out there, what's being sold, and to have some minimum standards of the environment that the systems are going to have to operate in going forward, as use does change.
And I think that along the same lines, the gentleman from the GPS community yesterday said we're going to go to wider band functionality. That suggests an encroachment further into adjacent spectrum. And nobody for a minute would doubt the value of GPS, but if the public safety people were here today, they'd say that their mission-critical push-to-talk communications are equally important when you're trying to say into the phone, don't shoot, and all they hear is shoot. So, and of course, if you're calling an ambulance for someone having a heart attack on your cell phone, it's a critical communication. So I think, you can go across the, no pun intended, spectrum of uses, and lots of communications are critical. GPS is critical, but I think the fundamental point comes down to, if we're going to share the spectrum, not necessarily dynamically, but ultimately dynamically as well, you have to have rules, and you have to have procedures, and you do have to have, as Dean said, a rule of law and a process to enable everyone to use the spectrum. You really can't have kind of an evolutionary squatting over a period of decades.
I think we're probably just pretty close to any. So there's a couple other questions here I'd love to ask, but I'm afraid they would immediately launch it. What? You do one. I can do one more. Oh, okay. No, I've shuffled them now. Okay, here for Pierre. Most interference occurs when a receiver and a transmitter are in close proximity. Something can be predicted and controlled quite easily. That can be predicted and controlled quite easily by specifying a transmitter power limit at the transmitter output. So why is it necessary to specify PFD throughout space? Isn't that overkill?
I think I know who asked that question.
Hello, John. Can we get handwriting samples from the room?
Yes. I think the way I'd begin to answer that question is that for handsets, if you're looking at the interaction between the handset transmitter and the handset receiver, that in fact is very often the case. And in fact, that's what the FCC does. It specifies for unlicensed devices and for handsets, specifies the handset power. But I think when, at least as I understand it, you're looking at transmitters, base stations, fixed stations, there are many ways in which one can actually arrange the deployment of those towers. So you can have one high tower, high power, all the way down to femtocells.
And with down tilt.
And so I think if one were to say we'll specify the transmitter power for base stations, given the very heterogeneous HETNet kind of architecture we're looking at in the future, the FCC will actually end up specifying a very large number of admissible transmitter powers, and associated with that another large number of parameters associated with how high it might be, what kind of down tilt it might be, and exactly what those transmitter parameters might be. But more discussion later, I think.
Okay, I think I'll thank all of our panelists. I really enjoyed it. Julie, we'll turn it back to you for
thanks, Dale.
Wrap up.
And I'll make this brief. At the start of the workshop, I had listed 3 goals. First was understanding and education, and the second was to draw on our experiences and see what we could take away from them, and the third was to identify possible ways ahead. And I think the workshop has been an outstanding success on all 3 of those goals. I couldn't possibly summarize all of the things that we learned or ideas that were put forward in the workshop. We had a really rich take of things. It's going to take some time, I think, for the Commission staff to digest it all and think about where do we go from here. I hope all of you who were here learn things yourselves and go away and think about this a bit more as well. I think, as Dale said at the start, the overall sense here is that something needs to be done. We don't know what that is, and I would just caution that does not necessarily mean we're moving to regulation. I mean, we had a lot of ideas here about ways to tackle the problem that may not involve regulation, and it really is. I would take this up a notch. When we start to talk about receiver standards and interference protection and so forth, we sometimes lose sight of the fact of what this is all about. It's about providing opportunities for new services, for innovation, for investment, and providing a stable environment both for the incumbents who need certainty. People expect the devices that they purchase to continue to work for a reasonable period of time. At the same time, we need to provide that certainty for the newcomers so that they know when they're investing in creating a new service that there aren't going to be unforeseen problems down the road. And who said that interference protection and poetry can't mix? There are a bunch of people I'd like to thank. When a conference like this comes together and it all goes smoothly, it looks easy, but it's not. In OET, for Walter Johnson in the back, and Michael Ha, who did a lot of the heavy lifting in organizing all of this. John Leibowitz, I don't know if John is still in the room. Tom Peters, Charles Mathias, Chris Elsa, and Cecilia Solhoff, all from Wireless Bureau. Evan and John. Evan's not going to agree with my thank you, I hope. Also from CGB, Denise Jones and Celeste McRae and their staff, who've been taking care of a lot of the work you see going on the side and just the setup of the room and so forth. We didn't have all of the bureaus and offices that were directly participating in organizing this, but I can tell you that we all work very closely together. There were representatives here or listening in on the floor from some of the other bureaus, the Media Bureau, Public Safety and Homeland Security Bureau, the International Bureau. So this dialogue that we had really informs the entire agency. So thank you all. Lastly, before I forget, want to thank all of our speakers because you made the conference. We could not have had the kind of robust discussions, and I don't think we cut corners on any of the issues. And that's what we were out to do. You can't solve the problems unless you really bore down into understanding them and get to the heart of the matter. So thank all of our speakers. Thank all of you. Have a great rest of the day, and thanks a lot.